All right, so some of the things that we just have to remember. Newton's second law. Hold on, I'm turn it if I could write better. Right, so we need to remember little things about Newton's second law. Newton's second law says that the resultant force is equal to mass by the acceleration of the object. So what it says is once an object has a resultant force, the object also has an acceleration, right? They both go hand in hand. Oh crap! I'm just up on it, right? I'll start over there, right? So Newton's second law, right? Once an object has a resultant force, right? Once an object has a resultant force, it has an acceleration. So a resultant force implies an acceleration. And we technically have been using this all the time, right? We've been using this all the time when we say weight is equal to mass by gravity. All right, so we have been using this all the time, right? Of course, we know all the SI units for all the little things, right? But that's basically what you need to remember. Once an object has a resultant force, it has an acceleration. And as we said in Newton, second law, first law, we says that once an object has no acceleration, then the resultant force is 0. Okay, so that's just something small for us to remember. Right, and as I said, we've been using this one all the time, right? Right, so let's see, we had something like this. So watch it here. Let's say we had an object, right? And the object is being pulled along a surface, right? It's pulled with tension T. It has a weight. It has a weight of 5G, right? G is gravity, right? Let's use gravity as 10, right? Of course, it has a resultant force acting on it, and it's being pulled, and it has friction. Okay, so you have a particle of mass 5 kilograms is pulled along a rough horizontal surface, right? It's a rough surface, right? So it has friction, and by a string which is inclined at about right, this is inclined at about 60 degrees to the horizontal. If the acceleration of the particle, so I've given you the acceleration, if the acceleration of the particle is 1/3 of gravity, and the coefficients of friction, so we have the coefficients of friction as well. The coefficient of friction is 2/3. They want us to find tension. So let's see if we could find T. All right. So how do we work this out now? In order for us to work this out, we need to remember, right? We need to get a few things, right? And one of the things that we're going to use is we're going to be able to see, because the object has an acceleration, right? We know that, what's the acceleration? Yeah, because the object has an acceleration, we know it has a resultant force, and we could find that resultant force horizontally. Okay, let's see if we can apply that. So we know that since F is equal to ma, that's how we get to apply the Newton's second law, right? That's resultant force, right? Please remember that this acceleration will be horizontal, right? This acceleration will be horizontal, right? What's the mass again? The mass is 5, and the acceleration is 1/3 by g, right? The acceleration is 1/3 by g. Let's plug it in one time. Let's plug in g as 10. Right. And because the object acting horizontally, the resultant force from the Jude by Ecomuto. Right? The resultant force is the resultant of, remember it's horizontal, this force and the component of this force. So anybody remember what I have to do with that tension force? What do I have to do with that T? Why the hell did I do that? Why do I keep doing that? Oh Lord. I keep pressing that stupid X. Oh, let me draw it back. I probably remember everything I just make up there. Anybody else drawing it? Right, I think this was 60 degrees. I remember the weight being 5 by gravity. It had friction here. It had the resultant force R. Acceleration would have been this way. Acceleration was 1/3 G. We had to find F, right? We move from there now. You're in front of the thing. Find F. What was mu again, Olia? What was mu? Two-thirds. Mu was 2/3. All right, good. So, so I said I was going to apply Newton's second law one time, right? I was going to apply Newton's second law, where the resultant force, remember the object moving horizontally, right? The mass would have been 5 kilograms by the acceleration, which is 1/3 by G. And the resultant force would have been the resultant horizontal force. And I was just asking what to do with T, and somebody tell me to resolve it, right? So here will be T cos 60, and here will be T sine 60. Okay, so the forces that contribute to the acceleration will be T cos 60 minus friction, right? Right? So let me I just use it F alone here, right? Nice. So how will that look now? Well, the horizontal force will be, right? The horizontal force will be T cos 60 minus friction. All right, in the whole word, right? Is equal to 50/3. Right? So T cos 60 minus friction is 50/3. Right. Here's the problem. We don't know T. Right? That's what we're trying to find. And friction is mu R. Right? Remember friction, that's mu R. Right. We have mu. But we're in problems. We don't know what is R. Right? We don't know what is R. So we're going to have to find a way to find R. Well, because the object moving horizontally, right? Then we could say, right? We could say that R plus T sine 60 is equal to 5G. Right? We could say that they're equal because there is no resultant force horizontally. There's more motion, vertically. There's only motion horizontally. Okay, so we could say that the upward force is equal to the downward forces. Right? And from this, we could find R. R is equal to 5G plus sine 60 is root 3 on 2. Right? Actually, I taken off that one time, right? G is 10, so 5 by 10 is 50. So we know that R is equal to that. So we're gonna substitute R, and we'll end up with T. Cos 60 is a half, right? So T by a half minus 2/3 by 50 plus root 3 on 2 by T is equal to 50 on 3. So I substitute for R, right? Nice. And all we have to do here is just solve for T. Right? All we have to do here is just solve for T. How are we doing that? Let me get rid of them fractions. Multiply by 6, right? So you'll get 3T minus 4 by 50 plus root 3T. Why did just multiply by, oh yeah, I see why. Is equal to 3 into that. 2 is equal to 100. Well, you can solve it, not we get the same thing. 3T minus 200 plus 2 root 3T is equal to 100. Carry everything on this side, numbers on this side, that's 300. Then factor out T, 3 plus 2 root 3, and then solve for T. So I have 300 over 3 plus 2 root 3. How much is that? Shouldn't R equal to 50? Shouldn't R equal to 50? No, we remember R have the upward force of the upward force is R and T sine 60. So those two forces are equal to 5G. Right, so R won't be 50 alone. You will have to include that T sine 60. All right. So these questions, you have plus. Oh, right. Oh, you meant minus. Yeah. I make a mistake here. That should be minus. Thank you. That should be minus. If V was paying attention, you would have realized that too. But he not. $50 minus root 3 on 2. And I magically get back plus here. What kind of? Right? I still end up with the same thing. Because I magically had plus here. I don't know how. That's okay? Still get the same answer. But the first part on top was wrong. That's okay then, Christopher? So what we recognize here, this is just like a question that we've been doing all the time. The difference here is that this object had acceleration. It wasn't in equilibrium. So once you see it have an acceleration, you have to apply Newton's second law. That's all. That's the only difference of the questions that we've been doing all the time with acceleration. sorry, resolve it. Now we have to apply that if the object has an acceleration. All right, while you're fresh, let's do a third law one time. But let me show the writing it because this I don't know why I keep removing the screen. But let's make sure you write it. So Newton's third law now. Newton's third law has come a lot, and it's probably the best thing that you will, probably the best question that you will get. So Newton's third law, we know what it states, right? Newton's third law states that every action has an equal opposite reaction. So these topics, these questions are applied to connected particles, right? So if you have a pulley and you have two connected, but you have two particles connected on either side, of course, one will be heavier, right? Let's say this is M1 and this is M2. Let's say M2 is heavier than M1. When you apply Newton's second law here, here's how it applies, right? If M2 is more than M1, then the object will move in the direction of the object will accelerate in the direction of M2, right? So it will have an acceleration there, and because they're connected, it will have the same acceleration on the opposite side, right? So M1 and M2 will move with the same acceleration, right? You'll also notice that it'll have tension acting here, and it will have an equivalent tension acting here. Because they're connected, they share the same tension and they share the same acceleration. In the other forces acting, M2 will have a downward force, which is its weight, M2G, and M1 will also have a downward force, M1G. Okay? And that's basically the setup there. Okay? So for M1, Newton's second law, the resultant force is equal to mass by acceleration. So since the acceleration going up, the resultant force is up. So it means tension positive. So it's tension minus M1G is equal to M1 by E. That's the equation that we get with respect to M1. And then with respect to M2, the acceleration is downwards. So M2G is downward, is positive. So M2G minus T is equal to M2 by E. And now you have what? You have this equation, and you have this equation, and you can solve for T and E. Okay? And that is in Newton's third law. Right? You'll recognize it in Newton's third law. They also have second law as well. Right? These are the best questions. You see this, I get happy because there's a plug in M1, M2, and you're good to go. You could find A and T. It's a basic solvent simultaneous, right? These are the best questions. Right, so as I told you before, this is like the end of module 3, right? All you have to take a look at after is momentum, right? After momentum, you have some projectile motion, and then a little application of energy, and that's it for this module, right? So we're down on the end. All right, let's try one now. Meet me in the morning. Oh, anybody writing? Sorry. And these equations are 90% of the time how they look, yeah? Of course, I will complicate it in a little while and put it on a plank, right? Meet me in the morning. Anybody writing it? Only have a screenshot, right? Okay, good. All right, so try this. Two particles of mass 5 kilograms and 3 kilograms are connected by a light inelastic string. 2 kilograms of masses, 5 kilograms and 3 kilograms are connected by a light inelastic string passing over a smooth fixed pulley. Find the acceleration and tension. Find the acceleration and tension. Right? So all you have to do is just drop just use the mass, right? One is 5 and one is 3 kilograms. No, I'm not writing. I just telling you what to do. Find the acceleration and tension. 5 kilograms and 3 kilograms. Right? We remember that G means gravity, yeah? And gravity is 10, right? Use G as 10. Right? Message and answer. I'll give you a few minutes again. So you just set up the equations and solve simultaneously. Should be done by now. Well, if you're doing it, that is. All right, so here is your tension. Here is your tension. It will go this way. It will go this way. All right, because the 5 heavier than the 3, right? So that will be 5g minus t is equal to mass by acceleration. That's the first equation, right? Next equation will be t minus 3g is equal to 3, right? And then, of course, we're going to add both of them. So this is 8 by acceleration. Tensions will cancel. 5g minus 3g is 2g. We're using gravity as 10, right? So A is equal to 2 by 10 all over 8, right? 20 on 8. What is that? That is 2.5. Right? 2.5. Okay, 2.5 meters per second. And tension is 5A plus 5G. You can use any equation you want, right? So that's 5 by 2.5 plus 5 by 10. So what was that? That's what? 12.5 plus 50, 62.5 newtons. Is that correct? 62.5. Anybody get that? No? Add wrong. What add wrong? What add wrong? Oh, I put tension in the wrong place. So when I move tension, I forget to move 5e. So this should be minus. This should be minus. This should be minus. So that is what? 37.5. Add the 5 here. 37.5. Somebody get 31. Anybody else get 2.5? Killing us soils. Yeah. That's okay, Olio. All right, let's go on. Let's do one more, but I want to make it a little harder. All right. All right. Good. Let's move on from that. Let's try the next one, right? I'll do this one for you, right? I'll draw this system and then you just set it up, right? I have a pulley here this time. Right, I have a pulley here, right? You have one here and you have one here, right? It's accelerating this way. Oh gosh. It's accelerating this way, right? Has acceleration downwards here. Here's a weight of 2G, right? Tension, right? Has a weight of 4G, tension, right? And the angle here is 60 degrees, right? So I'll just read it for you. A particle of mass 4 kilograms rests on a smooth plane, which is inclined at 60 degrees. Of course, it could be on a rough plane as well, so you had to add in friction in that case, right? So a particle of mass 4 kilograms rests on a smooth plane, which is inclined at 60 degrees to the horizontal. The particle is connected to a light inelastic string, passing over a smooth pulley at the top of a plane to a particle of mass 2 kilograms, which is hanging freely, right? Find the acceleration of a system and the tension of the string, right? Do your thing there. Let's see what you all come up with. Same principle. You have to get two equations with T and A in it, and then solve simultaneously. All right? Do your thing there. Hurry. All right. So let's see if your equations are correct. Right? So your first equation, I'll do the easy one. The one with 2G, right? The one with 2G will be 2G minus tension is equal to the mass, which is 2 by the acceleration. That's the first equation. The next equation, now the one on M1, you have a little problem there because tension and the mg force are not along the same plane. So you have to resolve mg, right? So you have to resolve mg along the plane, right? You don't need to resolve it parallel, perpendicular to the plane because nothing acting there again, right? Besides r, and there's no friction, so we don't need to find r. So when you resolve parallel to the plane, remember, it's 4g sine 60. Good. So we're good to go. We have the two forces that causing the acceleration. So we could say that tension, right, minus 4g sine 60 is equal to, what's the mass again? 4 by, and the mass wasn't killed, right? 4 by E, right? That's the mass of the object. So T minus 4g sine 60 is equal to 4E. Right? Then Let me do the same thing again. Now we add up here. So this is what, 6a, right? And then minus t plus t, that will cancel off. And then you will get 2g minus 4g sine 6t right? How much is that? Anyway, just remember what the whole thing is. 2g minus 4g sine 60 all over 6. Minus, okay. Minus 2.44. So what does that minus indicate, Olia? What does that minus indicate? Yeah, I get it. I wrote the direction wrong. It actually going the other way. Okay, so it actually should be going the other way, right? And then solve the tension from now, please. Tension is how much? Just plug in A, right? $2,000. So much? 24. Oh, okay. Anybody else got 25? Approximately 25? Anybody get approximately 25? Yeah? Okay. Okay, so those are Newton's laws, and those are the easy and as hard as it's come, right? All right, so those are your Newton's laws. All right. Next thing we have to look at is momentum, right? Right, all this should be good, right? So I'll continue in one time. So some of the momentum questions, I just did this real simple. You don't see nothing hard in this, right? These momentum questions are purely physics questions, right? And there isn't anything too difficult in these. If they come, there's nothing too difficult, but you must know how to find momentum. Okay, so we need to remember a few things about questions like this. So what is linear? What is linear momentum? If I give you an object of a particular mass with a velocity, linear momentum is the product of mass and velocity, right? But what you need to remember is that linear momentum is a vector quantity. So momentum in one direction will be positive. Momentum in the opposite direction will be negative. Okay? So just remember that, right? And there is one conservation that we need to learn, right? Again, physics people will know this. If you have two objects and they collide, right? This is before they collide. And two objects, let's say they move up this way after they collide, right? After they collide, what you need to remember that the momentum before collision is equal, total. So the total momentum before collision is equal to total momentum after collisions. All right? So you have to add the momentum before and add up after and equate them. All right? I'll make sure I'm doing one, don't worry. I'm doing one in case I'll forget about this, right? And the only thing new that you need to know, for those who are not doing Cape physics, we need to know about a quantity called impulse, right? So impulse, the impulse of a force, right, is equal to the change in momentum it produces. So change in momentum it produces, right? So it's like saying mv minus mu, right? That's the change in momentum and that's the impulse. So it's mv minus mu. Anybody remember the next formula? How else you find impulse? Have a next way to find impulse as well. Besides mv minus mu, there's a next way to find it. Anybody remember that? P by T momentum. Nah, not P by T. It will be F by T. At least you get the T right. You get the TP, you get the T part right. Very good. But you leave out the F. Very bad. All right. So those are the two things that we need to know about momentum. How to find momentum in a collision, apply the conservation of momentum, and what's the impulse of a force. Right? It's not that popular, right? But you will get, you may see something on it, right? Let's try one little question now. Oh, anybody writing? Screenshot of that. Screenshot it up. Ugh. Don't tell me that all, baby. Okay, let's try one there. So the first one that we're going to try, a truck of mass. So let me drop a little truck here. A truck of mass 10 to the power of 3 kilograms, right? Traveling at 3 meters per second is brought to rest, right? So somewhere down the road is brought to rest. Let me say right about here, right? And is brought to rest in 2 seconds. When it strikes a wall, right? Was the force exerted by the buffer? What is the force exerted by the wall, right? So let me say there's a wall here. They call it a buffer, right? What's the force exerted by the buffer? So we can do that now. See if you can do that. If you want a little hint, you're using this right here, right? You're using that relationship there. Try it quick. Let me see what you get. Don't tell me that yours, baby. Remember, it's 10 to the 3, right? All right, so let's see. So in order to work this out, we need to remember that F by T is mv minus mu, right? That's basically the impulse. The impulse is F by T. So we know that the mass is 10 to the power 3, right? The velocity is 3. And the fine, oh wait, I have it back to front. Right? There should be 0 here, right? And the next one is 10 to the power 3 by 3. We're trying to find the force that acts for 2 seconds. So F is equal to 3 by 10 to the 3 over 2. That's like 3,000 divided by 2. So that's 1,500. Right? Notice the negative sign because it's a force acting in the opposite direction. Right? It's a repulsive force. Don't tell me that yours, baby. All right. Let's try one with the collision now. No? Okay, next one. Let's try this one here. This is a collision, right? So a truck of mass 1,200 kilograms. I'll go along. I'll help with the diagram, right? So you have a truck, right, of 1,200 kilograms. Is moving with a speed of 7 meters per second. When it collides with a next truck of mass 1,600 kilograms, that's stationary. So the velocity is 0. Right? That's before. And now they said if the two trucks are coupled together, so they kind of stick up now, right? They stick up as one. What speed they move off with? So they want you to find the speed v here. Of course, if they stick up together, it'll be 1,200 plus 1,600 kilograms, right? This is after the collision. So find the momentum before and after and tell me what you get for v. Quick. Right? Remember to stick up together so they have one velocity. Don't tell me that yours, baby. Yeah, message one time. Message one time. Don't tell me that yours, baby. Nice. Send them quick. Yeah, you're done. Try to work it out now. All right, let's see what you got now. Let's see what you got. So the momentum of the 1200 will be 1200 by 7. The next one is 0. Is equal to 1200 plus 1600. Oh no, my pen gonna die. By V. So V is equal to, right? V is equal to 8400 over, what is that? 2800. That will cancel. How much is that all, yeah? 3. Yeah, that's 3 meters per second. All right. So that's how you work it out, right? Okay. Let's go again now. Actually, that's it. I ain't doing any more of that. Right? That's not really a big topic. The next thing I want to do is equations of motion, right? Take a little 4 minutes. I'm gonna just charge up my pen and then we're gonna take a look at projectile motion. If you don't need a break, just do me a favor now. Look back at equations of motion. We're going to use those to prove everything in projectile motion, right? Okay, take a 5 minutes and then we start back again. Don't tell me that yours, baby. Wait, now today is that game? Oh no. That game is Ray, were you any bothering me for by module 2? Send me your module 3 there, Ver. And we'll see how it look. All right, let's start about there. Like 5 minutes. That's 4. Oh, sorry. I apologize, Jude. I do apologize. Sir, is it really till 8 tomorrow? Who's this? Who's this? Yeah, boy. Yeah, boy. All right. It's nasty, boy. Don't touch up nothing. Go and beat. All right, so let's take a look at the quickly at the equations of motion, and we're going to do a few things with them for projectile motion, right? So we're looking at projectile motion now. Right? You do it in physics, you're good to go. Same thing. Nothing new. All right. So let's make sure you remember the equations of motion. So V is equal to U plus AT. V squared is U squared plus 2AS. S is equal to UT plus a half AT squared. Right? So you're using those three equations, right? And each of these equations, you'll recognize they have acceleration. So when talking about projectile motion, you will talk about vertical motion. So you're using any of these equations for vertical motion. And then you have horizontal motion, right? The only equation that you could use is speed is distance on time, really. S on T to be exact, right? That's the only equation that when it comes to horizontal motion that you will be using. And that's it. Okay? Right, so what's projectile motion? If I were to project an object at a velocity u, with a velocity u, at an angle theta to the horizontal, its path will be parabolic, right? Its path will be parabolic. So what you will recognize at this point, it will be traveling at a tangent, right? It will have a horizontal velocity because it's at an angle, right? It will have a horizontal velocity and it will have a vertical velocity. It will also have a vertical displacement and it will have a horizontal displacement. All right. So what do we do? What do we do if we know those things? Well, firstly, we could find the initial horizontal velocity. That'll be u cos theta. We could find the initial vertical velocity. That'll be u sine theta. And we could use this to find anything we need. What we need to remember, as I pointed out in one of the questions, the vertical motion is affected by gravity. Gravity acts vertically downwards. But horizontal motion not affected by any of those things. So you would recognize that the horizontal velocity is going to remain constant. So if at any point in time you want to find the vertical velocity, you're using these equations here. All right. So the horizontal velocity is not affected by anything. So you'd recognize it's not affected by gravity. So you'd recognize it's still constant. But the vertical velocity will always keep changing because of gravity. Right? So let's say you want to find the vertical velocity. The vertical velocity, you could go to equations of motion and you could use any one with v in it. So you could use equation 1 or equation 2 and solve for what you need. Let's use equation 1. So the vertical velocity will be the initial vertical velocity plus the acceleration. But please remember that if you're going upwards, it's minus g. If you're going downwards, it's plus g. So you'll notice I'll put minus g here by time. Right? That's the way you find your vertical velocity. And well, your final horizontal velocity is always the same as this here. U cos theta. Right? It's always going to be the same. Right? And if I ask you now, you have horizontal and you have vertical. If I ask for V, V is the resultant of both of them. So you find the resultant of the vertical and the horizontal. What they like to ask you in applying, they like to ask you about the path, right? They like to ask you about the path. So you're going to have to be able to show that the path is, of course, maybe is a parabolic path. So how do we show that? The parabolic path will be shown by finding y. If we map out y over the entire journey, right, y should follow a quadratic, ax squared plus bx plus c. It might look something like that. So let's see if we could find y. So before we find y, let's find s, of course, right? How do we find x? X is the horizontal displacement. The only horizontal equation we have is this one here. So horizontal displacement is horizontal velocity by time. Horizontal velocity is u cos theta, and you're multiplying that by t. Okay? So that's your horizontal velocity. Now, how do we get y? Sorry, that's your horizontal displacement. Sorry about that. How do you get y? Well, let's come here now. Let's see what we can find for y. So y is the horizontal displacement by the initial horizontal velocity. Sorry, vertical. By the initial, I'm using everything in here, vertical. By the initial vertical velocity by time plus a half by minus g by t. And then we're going to substitute. From this equation here, we can solve for t. T is equal to x over u cos theta. So when we substitute, we'll get y is equal to, remember uv is u sine theta. You're multiplying by t, that's x over u cos theta minus g over 2 by t, right? T is x over u cos theta. In doing this, sadly, you need to know about sec and thing all, yeah? You need to know about sec, and you need to remember your sine A plus B rules and thing. I saw a question where, it's an older one, where you had to use sine A plus B and thing to figure it out, right? So when you multiply this out, you'll get u, the u's will cancel, and you will get tan theta multiplied by x. I'll leave out a squared here. Minus g on 2 by x squared u squared cos squared theta. So y is equal to tan theta minus x minus g over 2u squared cos squared theta by x squared, right? This here, 1 on cos squared is sec squared. So sometimes you will see the projectile, let's call it the projectile equation. It looks like this. Minus g over 2u squared sec squared theta x squared. Gil, move that thing from there now. I can't write. Thank you, Gil. Plus tan theta by x. And if you look at this closely, this is a quadratic. That's A and that's B, and well, C is 0. Right? So that is your projectile equation there. That's what you use to show that it travels on a parabolic path. Okay? So I showed you how to get y at any point in time. I showed you how to get the projectile path, right? Our next formula that is using applied sometime. You don't have to use this. You could use the equation of motion. Sometimes they ask for the horizontal range. That's the full journey horizontally. And r is equal to u cos theta by t. And then sometimes there's asks for, there's our next one, right? Time for entire journey. Time for entire journey. You'll end up with t is equal to 2u sine theta on g. Okay? So those are some of the things that we need to know. Most of you all know this from physics already. All right? But let's see if we can apply it. And again, I want to stress on the fact that once you could use the equations of motions, good, you don't need anything else, huh? You don't need anything else. Okay? Screenshot that now. Let's take a look at some past papers. Meet me in the morning. Jesu. All right, let's try one now. Let's see if we could get 2017. I think I have that here. Hold on. Meet me in the morning. Right, that is not applied. Where is applied? Applied Maths Unit 2, 2019. I think I have one. What we gonna do? We go look. Let me look. Let me look. Let me look. 2 time I cook. Nobody eat the food that I cook. 4, 5. Ooh, look a little projectile here, man. We in the game. Yeah, man. 20. I forget what year I say. 2019. We in the game. We are gamed. 2019. Let me go about here. Chi-squared. 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 All right. Meet me in the morning. Where it gone? Oh, there she is. Right. Ooh, and it was good to you too to give me a diagram. So take a little read. Let me see how we're going about this, right? I will help you since it's the first one. Physics people, all I could go right ahead. Anybody here not doing physics? 1, 2, physics people, man. Forward to the physics people. Take a little read and let me see if we could do some work on it. What you say? What you say? What you say? What you say? Oh, yes. Meet me in the morning. Find theta, that's the first part. So a ball is projected with a speed of 40 meters per second from a point P on a cliff above a horizontal ground. The point O on the ground is vertically below P. OP is 36 meters. Why will you keep asking with question? Find the value of theta. You're not saying that? Value of theta, 3 marks. How what? Oh, you're not seeing anything. Oh, that's what I mean. It's showing my whiteboard. All right. The whiteboard go now? That is what you mean. Them chupid so by very right. Just say because see nothing. Weird question. Weird question. Well again, like beer. All right, so y'all seeing this now? Seeing that now? Right. So they give you that question. This is 2019, right? They give you that question there, and they want you to find theta. How are we doing that? Right? Sometimes, like when you see 3 marks, you might end up with using a couple of formulas. But when they when they have their solution, they kind of assume you'll use some of the proven formulas, right? But I don't like to use that, right? Let's see if we could work it out. So the questions show you that the highest point is 12 meters, right? And they want you to find theta. So we know at this point, we know the final velocity is 0. Okay? So see if that can help you now. Let's see if we could find for theta. Time to reach maximum height. Jesu, go and beat. All right, so v is equal to 0. Right, so how do we work out that? Well, we know at max height v is equal to 0. Right, so and we know the initial vertical velocity, that'll be 40 sine theta. All right, and we also know the max height. We know s is 12. So we could go to the equations of motion and use which one we could use? V squared? Yeah, because we don't know time, right? So we could use v, go on, beat from my place. V squared is equal to u squared plus 2as. Right, the final velocity is 0. The initial velocity is 40 sine theta, both all that squared, right? Plus 2. Gravity is minus 10, right? And the displacement is positive 12, right? So you do a little thing there, that'll give you 24, that'll give you 240 is equal to 40 squared. What's 40 squared again? 1600 sine squared theta. Right, so we know the final vertical, the initial. So we know this, the final velocity vertically. We know the initial velocity vertically. We know the acceleration vertically. We know the displacement vertically. We know everything vertically, so we got to go. Right, so you will get sine squared theta is 24 over 160, and then you square root it, and then you find theta. Theta is sine inverse square root of 24 over 160. 40 squared, correct, right? Treat me in the morning. Right, tomorrow again now. Right, so that's showing you how I use the equation of motion, right? Don't tell me that yours, baby. Boy. Right? How much here? 22.8. All right. So theta is 22.8. All right. Next one. Next one is find OR and then the speed of the ball as it hits the ground. Find OR. Let's make a note of it now. Find OR and the speed of it just before it hits the ground. I'm going back to the diagram, right? Find OR. I will see if Antonio was send anything. I might just message your mom there. You can send me something after this. Right, so you want to get that horizontal displacement, right? All right. So you want to get that horizontal displacement. Right, so the only equation is displacement is horizontal velocity by time. It's easy for us to get the horizontal velocity, as that will be 40 cos theta, right? Which was 40 cos 20. I forget. What was it again? 22.8 or something. 22.8, yeah. 22.8, right? So that's the horizontal velocity. How much is that? How much is 40 cos 22.8? How much is that? 40 cos 22.8. 36.9. So that's the velocity horizontally, right? 36.9. Now here's the problem. The problem is we need to find, we know this, right? We need to find this time. How are we doing that? Any ideas? Anybody have any ideas? Don't tell me that yours, baby. First equation. Which one is that? Which first equation is that? If V is equal to U plus AT or the S? V is equal, okay, so we know no, we can't use that yet. We don't know the final velocity here. Right, we don't know that as yet. Right, the hint is something to do with this. Something to do with the 36. Move from here to nasty yourself from a place. What? Nah, it won't be 0. So, right, so because we have this here, this is our displacement, right? So the particle vertically went up and come back down. So the displacement is minus 36 meters. Minus because it went below the starting point, right? So now we could use S is equal to UT plus a half AT squared. You all done plenty this in unit 1, yeah? S is equal to UT plus a half AT squared. S is minus 36. U is the initial vertical velocity, right? U is the initial vertical velocity. No, you wouldn't add the 12 because the displacement is the distance from where you start to where you finish. If you add the 12, that's total distance traveled. That's totally different. That's different. Our equations of motion is for displacement. Okay, so it's minus 36. And the initial velocity, well, vertically was what? 40 sine 22.8. We're trying to find time minus a half by 10, 0.5 t squared. Right? Simplify it and make it's a quadratic, right? Make t the subject of the formula. Tell me what you got.
What are you doing? What are you doing?
Shh, in a class, please. Why is it negative? Because if you start here, right? Everything here, everything until you reach back to your starting point is your positive displacement. Right? So everything on the top positive displacement. Once you go below, right, because it's a vector quantity, everything below will be negative displacement. Right? So once you go below the starting point, right? Once you go below the starting point, it's negative. Okay? Right, Gail? Yeah? Okay. Right? And when you solve for T now, one person got 3.42. Anybody else got a 3.42? Meet me in the morning. Right? So when you solve the quadratic, you'll end up with T is 3.42. And then you come back here now and you solve for OR. OR will be 36.9 by 3. Hey, both of you. Right? So 36.9 by 3.42.
Take off this dumpling.
Okay, copy it down. And the last part is the one the velocity just before it hits. Right, the last part is they want to get the speed of the ball just as it hits the ground at R.
Take off this dumpling. Take off this dumpling. Take off this dumpling. Take off the dumpling.
Sorry, I was talking all the time. In order for us to get that velocity, right? In order for us to get that velocity, we're going to use the final velocity is horizontal squared plus the vertical component squared. We know what the horizontal velocity. That is always 40 cos 22.8, right? But the vertical velocity at that point, just before it hits R, when it hits R, we could use U plus AT. The initial velocity will be 40 sine 22.8 minus gravity by time. Time was 3 point, what we get again? 3.42. 3.42. Right? So you multiply that by that and you get your answer. Right? That'll be a vertical velocity. How much is that?
what?
18.7, right? Tons. Right? And then you add it to 18.7 squared and you get your velocity just before it hits. Which charger it up there? Yeah, my charger now.
Oh, and one?
My own. My charger. Take your time. No, not that one in there. Don't worry. Don't leave it. I'll come and get it.
The African one?
Yeah, but don't show it on my phone and then.
Yeah, that's one.
Okay? And when you solve this, you'll end up with how much? Right? So if you remember, for you to get velocity at any point, you have to use this relationship here, right? Any answer there? $41.3, thanks. So 41.3, right, meters per second, that's the velocity it will hit R with. Right? Remember that it will be a tangent, so it might hit it straight down like that. But not straight down, because remember it coming in like that, right? So a tangent might look something like that. So it will hit V with that velocity. It will hit R with that velocity. Right? After it loses its energy, then it becomes zero. Right? And that kind of brings us to what you will do in the last part. The last part is where we take a look at kinetic energy and potential energy. Kinetic energy is a half mv squared. Potential energy is mgh. And these type of questions, what they will want you to highlight is, for example, if an object starts here and finishes here, they will want you to show that the change in potential energy is a gain in kinetic energy, and solve any irrelevant things in between. Not seeing the, no, I'm not using the whiteboard. All right, in question. You all see what I wrote there for kinetic and potential? Okay. All right. So that is how the projectile questions look, right? Let's make a squeeze in one more now. And the last part is energy. And that's how to find energy, kinetic energy, and conservation momentum. And that's it. I'll show you an example lesson. Right? And that's the last thing in the module. Right? The next question I wanted to take a look at quickly is 2017, I think. Hold on. I think I have 2017 here. Wait, where's that? What just happened there? Don't tell me that yours, baby. Applied, 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 applied. Oh yeah, it's just 2024, 2022. Oh no, that's when I pull it up. 2016, I'm not sure if I have one. Let's give me a minute. I just want to pull back up our next one. Nah, this one had momentum and thing. Oh yeah, it's just 2022, 2017. I'll find it. You all seen 2017 there? 2017, I mean. Seeing the screen? You all seen that? All right, so let's try this last one here. Time to hit the ground. And then they want you to show the distance of the foot is that. You all seen the screen there? Seen the question? Hello? Anybody seen question? Yeah? All right. Try this last one now, please. All right, so let's see what you came up with, right? So an object. Oh no, I can't write. Why can't I write? I cannot write. I cannot write, my young one. I cannot write. Can I write now? Yes, I can. I can write. So an object on the edge of a cliff that is 45 meters above the ground. So you have a little cliff here. You have a little cliff here, right? That is 45 meters. It's projected with a speed of 20 meters per second at an angle. So you're shooting it at 20 meters per second, and the angle is 30 degrees. Right, with respect to the horizontal. If horizontal ignore, determine the time taken to hit the ground. So when it hits the ground, what do we know? We know that the displacement is negative 45. We just do that, right? We could find the initial velocity vertically, and we know the acceleration is minus g. Initial vertical velocity, that will be 20 sine 30. And we could use S is equal to ut plus a half at squared. S is minus 45. U will be 20 sine 30, that's 10. Why this thing giving so much trouble, right? Minus a half of g is 10, so minus 10 is 5t squared. So now we have 5t squared minus 10t minus 45 is 0. And that's it. Solve that. And you're good to go. How about yourself? Cause it's so that's the equation, right? How much is that? Sim Simma, who got the keys to my beamer? Anybody there? Anybody get value? So these equation and motion there and solving, right? What did you get? Minus? No, it's two values. And what the minus? What would I do with the minus? Oh, you get two positive values, 4.16 and 2.16. Serious? Both of them positive? So it's 4.16 seconds. Okay. So one positive, one negative, right? Okay, good. Free account, just stream me down game now. Right, and you have one more part. Right, we have one more part, is this. Should the distance from the foot of the hill to the point where it strikes is that. So you have to find like that OR distance again, right? Try that for a minute, find that distance and we're done. So you're finding this distance. You're finding this distance here. See if we get this value here. So x is displacement is equal to velocity by time. The velocity is the horizontal velocity, which is 20 cos 30, and you're multiplying that by time. You said was 4.16. Right? Oh shucks, they want it like that. You want to check it and see because I already rounded off from the first part. So we should have used like we should have used the exact value here. Right? But just work it out and see if we're getting the same thing. Oh, 1 plus root 10. Okay. So work it out for now, Christopher, and see if it's close to this 72.1 meters. What I mean? Thing now walking by. Yeah, good. Yeah, close enough. All right. Right, but to get it in this form, you would have had to use the exact value here and then plug it in here and work it out, right? All right. All right, nice. I want to keep all it much longer. So that is your projectile motion, right? The last thing that we have to look at, right, is basically things that we can do from physics, like energy and power and thing. Energy, right? The last things that we have to look at will be like energy, right? We know that energy is force by distance. And the two main types of energy is kinetic energy due to motion, potential energy due to position. And then if they ask for power, power is the rate of doing work. So that's work done on time, or simplify it a little bit and you'll get force by velocity. So that's the power delivered. And we need to remember one thing is the conservation of mechanical energy. All right, conservation of mechanical energy. Right, remember energy, right? Basically, what we're saying here is that the total energy always remains constant, right? So the total energy always remains constant, right? So how you apply it? You might apply it in systems, right? You might apply it in systems as they move down or something, right? As they move down, there would be a change in potential to kinetic. So it means that if you add up the potential and the kinetic, it should always be constant. Okay? So when you add it up, regardless of the change, you should always get constant value. All right, I don't really have much in this one. All right, but these are the things that you need to remember. I have one or two in somebody else, but I don't have that one written down. Okay, so those are the things that you need to do for this module.